My name is Jim Trudeau. I'm a Senior Application Engineer here at Cypress. And today we're going to be talking about the Peripheral Driver Library. And as a software developer, code examples are great. They show you how to do things, but ultimately you need to do something yourself. So this video is going to show you how to create a custom project for whatever part you're using and implement the PDL for that part. So to create a custom PDL project, there are a couple of things that you need to do at a high level. So let's walk through those, and then we'll do it for real using the tools. So the first thing you need to do, the PDL provides the configuration and startup files that you need for any part in the devices folder. So if you look inside the PDL folder, the PDL installation, you will see a devices folder, and inside the devices folder are packages for every single FM part. So the first thing you do is you make a copy of that template folder for your device. And then you need to add the PDL user.h file to your project. And we'll do that for real so that you can see how that's done. You need to include the PDL underscore header.h file because that includes all of the headers that are required to build the PDL code. And then you need to add the PDL source files. And again, we'll show you how to do this for real using the tools and discuss why it is set up this way. But using this process, you can create a project that has all of the appropriate startup code for the part that you're using. And finally, once you've done all that, because you're pointing to a variety of headers that can be in various locations on your particular laptop or machine, you will need to update the project's include paths, and we'll talk about that in some detail. All of this, don't need to worry about writing down notes. All of this is included in the PDL Quick Start Guide, which is part of the documentation that's installed with the PDL. There is a section in that guide on developing code using the PDL that walks you through this entire process. I've got my desktop set up with a variety of folders that are open to walk us through the process of how to get started from scratch. So one of these folders right here is, in fact, let's take you back to the top. Inside the PDL 2.1 is the devices folder. We're going to create a project for the S6E2GM board, which is sitting here on the desk. The PDL has a folder in it called devices. This is where all the startup code is for every part. It's organized by family. So we have the FM0 Plus portfolio and the FM4 portfolio. We're going to build for the FM4. And these are all of the FM4 parts. And the one that's on this board is the S6E2GM. And all we're going to do is copy that and paste it into wherever you would normally put your development projects. So I've got a folder called My Projects, and I will just paste it into here. And I'm ready to go. That doesn't get me entirely started, but this is where we begin. Once I've done that, I'll open that up. The common folder has all of the common source files that are used by all the projects, so we're good to go there. You don't have to touch that. And then there's the projects folder. And in the projects folder are a blank main.c and all of the startup code that's required for each of the IDEs. You can, of course, change the name of your workspace or project file for your IDE if you wish. So let's use the IAR tools and open up the project file. Okay, we've got the IAR tools up and running with what amounts to essentially an empty project, and our task now is to add the PDL related files. So let's shrink this just a little bit. You need PDL user.h. A reasonable thing to do is to go get one that's a lot like what you need. In this case, we're building an application that uses an ADC. So I've got the ADC code example open. I'm going to copy PDL user.h into my project folder. And then from the project folder, I'll add it to my project so it's easy to get to. I'm also going to need some source code. So in the PDL, in the drivers folder, I need the ADC source file. So I can just drag that into my project and add that. When you're building your own project, you would add whatever source files you need to implement for the peripherals that you're going to be using. The other file that I need, there is a general file called pdl.c. So I will drag that one in. So it's a fairly straightforward process. How you add files will depend on the IDE that you use, But the point here is pretty simple. You go to the PDL drivers folder or the PDL utilities folder and add whatever files you need to implement the functionality that you're trying to create. After you're done adding the files, you need to modify the include paths for the project. We can't do this for you because we don't know where your files are. You can install the PDL anywhere. You need a path to the common folder and the SimSys include folder. These are already set up for you in the template project. You need a path to PDL user.h. Remember, we added PDL user.h to the project. That lives somewhere. I don't know where you put it, so you need to add a path. So that depends on where you put it. You need a path to the PDL drivers folder. This will depend on where you installed the PDL. And you need to add a path to the PDL utilities folder if you use any of the files that are in that folder, and you probably will. In addition to that, you'll need to add any other paths that are required for the project as you create it. You may use a third-party library, for example. So that's enough theory. What I've done, you don't need to sit here and watch me type code. I'm going to switch to a project where I've done all this, and I've actually got two of them open. One is for the FM4, one is for the FM0. These use the identical source code. In fact, if we're looking at this, you can see that for the S6E2GM, I define that that's what I'm building for, and for the S6E1B8, I define that's the board that I'm building for. Other than that, these source files are identical. The only difference in the source code between these two is the pins that I'm using. For example, the FM4 board uses a light sensor as an analog source, and that's on a particular analog channel. That's just the way the board is wired. And the FM0 board uses the potentiometer that's on the board, and that's a slightly different pin because it's wired differently. Other than that, the only other thing that's required is that I have included PDL header.h. Okay, so let's walk through this code a little bit to see what it does. Remember that when you are working with the PDL, you need to configure, initialize, start, and then use the peripheral. So this is the code that initializes the ADC. We have a scan configuration that we set up, and we have the configuration for the ADC. Then once those structures are set up, we call ADC init, and that sets the peripheral up the way we want it to be. I don't need to know what registers are required. I don't need to know what bits in what register controls what feature of the ADC. The PDL handles all that for me. And then we start it up. And the API function call in the PDL for that is called enable wait ready. There's one more thing we want to take a look at, and that's this file PDL user.h. This is what configures the PDL as a whole. This is where I turn features on. In this little application, I'm using the ADC. So I have turned on ADC 0. There are 3 possible ADCs that I can use simultaneously. I'm only using ADC 0, and we're going to turn that on. And I'm also using GPIO, so elsewhere in this file I've turned on GPIO. So let's build a code. We'll click the debug button, we'll download the code, and in a moment the debugger will be up and running. And here we are. We'll click the go button. We're reading the light sensor on the board, and when there's a high signal, the LED is red. If I were to block the light sensor, it turns blue, and if we have an intermediate value, it's green. And so what the code is doing is reading the analog signal from the light sensor and adjusting the color of the LED based on the strength of that signal. And now for a little fun, let's do exactly the same thing, exactly the same code, running on an entirely different board. And for that, we have set up the S6E1B8. So let's unplug this one, and we'll plug in this board. And in the IIR tools, having started with the device folder for this particular processor, the FM0 Plus that's on this board, we will click the debug button, download the code. The only difference is, rather than reading a light sensor, we're going to read the signal off of the potentiometer. So we click the go button, and if the potentiometer is on low, the LED is blue. And as we crank the signal up, it turns green. And when we get up to the maximum, we're red. Exactly the same code, exactly the same peripheral on entirely different hardware. And that's one of the really cool things that comes out of the PDL. What we've seen here is that the PDL has some key advantages to you as a developer. You get the source code for the entire library, so you can create custom drivers for any peripheral. You get all the startup code and the configuration files you need for every FM0 Plus and FM4 part. You get fully configured project files for popular IDEs like the IAR or Kyle tools. You get a hardware-independent function API. You can write your code once and run it on any of the FM parts, and you're good to go. Programming a microcontroller may not be all that easy, but the PDL sure makes it easier. Thanks for watching.